Welcome to the first video for section 7.7. This first video is all about multiplying monomials. So monomials are those things where it's essentially maybe 8x. That is a monomial, and if we're multiplying them, this 8x could also be multiplied by 7xy. And so the answer there would be 56x squared y. So we're going to understand why that truly is. So let's go on to our first problem here. Our first problem, we have 5x squared times 4x to the third. So big thing, when I am saying this, I'm saying 5x squared times 4x to the third. So really all we can do is we could rewrite this whole thing as saying 5 times x squared times 4 times x to the third. And then we can put those parentheses back around there. Do we need the parentheses? No. In all reality, we have multiplication straight across all the way. So since we have multiplication straight across all the way, we can use the commutative property, which says that we can move multiplication around in any way, shape, or form we see fit, in any way we decide is best. So we can say 5 times 4, and then we can say x squared times x to the third. When we do the math, 5 times 4 is 20. And then this is where we're going to get confused. X squared times x to the third. Let's think of our exponent properties. This is from our multiplying exponents properties. Essentially what we're going to be doing is we're going to say x to the squared, or x squared plus 3. Or in other words, we have 20 times x to the fifth. Now let's understand why that is. We can say x squared is essentially x times x. X to the third is x times x times x. So how many x's do we have? 5 of them. There is our final answer for that problem. Let's do another one. Here we go. We have negative 3 times x to the third y squared times 4 times x times y to the fifth. Same as before. Let's actually put some of these terms together. Everything's multiplying straight across, so we can actually find what goes together. Let's do negative 3 times 4. We're going to write that together. Then we can put x to the third times x. And then lastly, we have y squared times y to the fifth. Y squared times y to the fifth. So let's do the math. Negative 3 times 4 is negative 12. X to the third times x, that's essentially x to the third plus 1. And then we have y squared plus 5. So that can all be rewritten as negative 12, x to the fourth, y to the seventh. Done. Final answer. Awesome. Last problem, let's look at it. Half, or 1/2, times 4 to the third power times b times a squared times c squared times 6b squared. So let's find those like terms. I have a half and a 6. There's no 1s, 2s, 3s, 4s. There's no numbers there with this middle monomial. So we can rewrite this as saying half, 1/2 times 6. And now we can see we have an a to the third and an a squared, and there's no a in our final term, so we have a to the third plus 2, or a to the third times a squared. Then we have a b and another b, so we have b times b squared, or b to the 1 plus 2. And our last term we have c. And it looks like that c squared is only in one of our monomials. So let's do the math. 1/2 times 6 is essentially 1/2 times 6 over 1, which is 6 over 2, and I multiply straight across, which is 3, so 3. A to the third times, or a to the third and times a squared is a to the fifth. And then we have b times b squared is b to the third. And last term, c squared. Done. Final answer. Hope this helps.